Okay, here we go. So today, you guys, we're going to be learning something called coterminal and reference angles. So just to give you some background, you guys, make sure you understand that a whole circle is 360 degrees, okay? So we'll start with this thing called standard position, okay? So standard position is an angle is in standard position if its vertex is located at the origin, which is right here, right? If its vertex is located at the origin and one ray is on the positive x-axis. So do you guys notice how that ray right there is on the positive x-axis? The ray on the x-axis, which is this one, is called the initial side, and the other ray, which is this one, that's called the terminal side, okay? Now, the initial side, the initial side, you guys, will always be right here on the x-axis, but this terminal side could change, okay? So the terminal side, you guys, could be here. The terminal side could be here. The terminal side could be here. So the terminal side can move, but then the initial side, you guys, will always be on the positive x-axis. And then this angle measurement will change based on the terminal side. But you always start on the positive x-axis, okay? Now, let me give you guys some feedback on the angle. So since you always start on the x-axis, if you guys go clockwise, so let's write this down. Clockwise rotation, that's going to give you guys a positive angle. Oh, sorry, counterclockwise. So a counterclockwise rotation, oh my gosh, that was almost like the end of the world type stuff. So counterclockwise rotation is a positive angle, okay? Clockwise rotation, this is going to give you guys a negative angle. Okay? So if you have a counterclockwise rotation, which looks like this, so if it goes that way, that's a positive angle. If you have a clockwise rotation, that's going to give you a negative angle. Okay, so that's just to give you guys some insight. Now we're going to look at more vocabulary, and this is one that we're going to be focusing on. So now we have something called coterminal angles, okay, you guys? And its two angles are coterminal if they are drawn in the standard position. Okay, well, that basically, how does that die? I don't understand. Okay, let me go. Okay, here we go. Bring it back up. Okay. Gotta love technology sometimes, right? Okay, so let me repeat this. So two angles are coterminal if they are drawn into the standard position, which is like this, right? Having an initial side, terminal side, and both have their terminal sides in the same location. So let me go down to show you guys this. And I'm going to erase this so that you guys don't get overwhelmed at first. Okay, so there is a terminal side right there. Okay, so this is what it means to be coterminal. So let's say you guys made an angle in standard position. So remember, this is always the starting point, right? The positive x-axis. And you go from the initial side to the terminal side. And let's say this is called theta 1. And remember, theta is just an angle measurement, and let's just say that's 45 degrees. So that is one angle measurement, but let's read what coterminal means again. It's two angles that are coterminal if they are drawn in the standard position, meaning they start on the initial side and go to the terminal side, and both angles have their terminal sides in the same location. So that is one angle, you guys. And now to make a coterminal angle for this angle, you just have to create another angle that ends up at the terminal side as well, but it starts on this initial side. So what you can do is, you guys, every time you have a given angle, then all you really have to do is you can add 360 to that angle measurement, or you can subtract 360 in order to find your coterminal angles. So for example, this is 45 degrees, right? If you added 360 to this, well, wouldn't that be a whole entire circle, right? So again, if you added 360 on top of 45 degrees, wouldn't that get you guys back to that same terminal side? And you would. So one angle you guys can say is, okay, another coterminal angle could be 360 plus 45 degrees, which means a whole total of 405 degrees would be a coterminal angle. And you could continuously add 360 in order to find other coterminal angles. Now, the same thing can be applied, you guys, if you did subtracting by 360. Now, recall that clockwise is positive, right? So remember when I did this, you guys, that would be a positive because it's counterclockwise. So that means you add by 360. Well, you can also subtract by 360, which means in order to subtract, you have to go clockwise, right? And that would lead you back to the same terminal side. So another way you guys could do it is whatever your given angle is, you can subtract by 360 to get other coterminal angles. So just to recap for you guys, two angles are coterminal if they are drawn in the standard position. Standard position just means they all start from the initial side. And both of their terminal sides are in the same location. So basically, if two angles end up in the same terminal side, then those are what you call coterminal angles. And to find coterminal angles, you either add by 360 to the given angle, or you can subtract by 360 to find your other angles. Okay, so I think this is an appropriate time for any questions. So does anyone have any questions on that? Like what the standard position means, clockwise, counterclockwise rotations, and what those means, or like what coterminal angles are. Again, this is really new to pretty much all of you guys, so questions are to be expected during this lesson for sure. So is there any questions, or do you guys want to just look at the example problem to try to get a feel for it? Yes. Terminal side is always a ray that goes away from the, well, initial side is always going to be on the x-axis, the positive x-axis. The terminal one is pretty much, as long as it starts in the origin and it's not on the positive x-axis, that could be a terminal side. So this could be a terminal side, terminal side, terminal side, terminal side, terminal side, terminal side. Any of these could be terminal sides. Yeah. Oh, yeah, I guess it could go away from the x-axis, but this could be also a terminal side right there, right? Yeah, good question. From the other two in the chat, how do you guys feel? Okay. Okay. Again, well, I'm gonna do a doyo for you guys as the lesson goes on, so you know. All right, so here's example one. So let's say they give you guys this angle, right? And it's 225 degrees given. And the directions are you have to find one positive coterminal angle and you have to find one negative coterminal angle. Well, remember, all they have to do is just end up here as well, right? And they have to start from here. Well, if that went 225 degrees, one easy way to find your coterminal angles, you guys, is to just add by 360 to that amount or subtract it by 360 from that amount. So if you, okay, so my first coterminal angle, so if I do 225 and then you add 360 to that, then that will give us our first coterminal angle, and that's going to be 585. Yeah. So 585 degrees would be your first coterminal angle, and a visual of that, you guys, would be 225 degrees, right? Like that, and then a whole 360. And then as you guys can see from the red, it ends up exactly right there. So that's what 585 degrees looks like. Now, that's one, but then remember, you gotta find a negative coterminal angle. So I'm gonna get rid of that. So to find a negative coterminal angle, you guys, I would just subtract by 360 from the original angle. So 225 degrees minus 360 is going to equal to 135, negative 135. So negative 135 degrees would be a negative coterminal angle. And that would be good because, right, if you went 225 degrees counterclockwise, then, well, if you were to subtract 360 from that angle, right, then that would mean you're going clockwise from that, and you would end up right there, right? So that certainly makes sense to me that we could subtract 360 in order to get there. Oh no, you don't have to draw it. I'm just drawing it to give you a visual on like why it works, but you don't have to draw it. This is the only requirement, if that makes sense. So then, um, if you were to just look at this as face value, negative 135 degrees, remember you always start here, you guys. That's the initial side. Negative 130 feet, no, negative 135. My gosh, I cannot speak. Would be like that. And that makes sense to me. So again, if you want to find your other coterminal angles, which means pretty much coterminal means it ends on the same terminal side, then you should add by 360 or you should subtract by 360 to find one positive and one negative coterminal angle. All right, so give this one a try. You guys are given negative 30 degrees. Find one positive coterminal angle and find one negative coterminal angle. I will give you guys, I think a minute and a half sounds good. Minute and a half? Yeah? I'll give you guys 2 minutes. Okay, 2 minutes. Try it out. Remember, find one coterminal angle that is positive and find one coterminal angle that is negative. 2 minutes, you're on the clock. got like 45 seconds left. 45. All right, time's up. So let's take a look. So remember, you gotta find one positive and one negative coterminal angle. So I'm just gonna go ahead and find my positive one. So even though that does say negative 30 degrees, I'm still going to be adding 360 to that. So if I add 330 degrees, so negative 30 plus 360, I'm going to get 330 degrees. So that's one coterminal angle, which is pretty much a whole 360 that way, right? So if you were to just look at this on face value, it would look like this, you guys. 330 from the initial side, go 330 degrees, and would lead you to that terminal side. Good. That's a coterminal angle. Now, to find a negative coterminal angle, let's subtract by 360 from that. So negative 30 minus 360 is going to be negative 390 degrees. So remember, if you went negative 360 degrees, that's going clockwise, right? So you would go negative, which is a clockwise direction, a whole 360, and it would lead you right back to that coterminal side. If you're curious and you're like, what does that look like face value? It looks like this. So remember, you just start from the initial side, you go a whole 360 clockwise, and then 30. And then see, it ends up right there, which is a coterminal angle. So that's pretty much how you guys find all of your coterminal angles. And you guys are probably starting to recognize there's infinite amount of coterminal angles, right? You can continue to add 360 or you can continue to subtract by 360. And there's just going to be an infinite amount of numbers you guys can find for coterminal angles. Does anyone have any questions about all of this stuff? So write down how you feel in the chat. If you have a question, then ask the question. Otherwise, just write you're good or not good, I guess, and then we'll move on. Yeah, so add or subtract by 360 to get from the given angle, and then that will help you find all your coterminal angles. One more person, how are you feeling about your current state about this stuff? Okay. So I think the most difficult thing about this, you guys, is just the vocabulary, right? It's just really understanding what all of this vocabulary is saying, right? Okay, last one, you guys. And this is what we call reference angles, okay? So reference angle, it's the smallest angle that the terminal side of a given angle makes with the x-axis. So when you guys take a look at this, okay? So these are your reference angles. So all of those rays, these are all different types of terminal sides, okay? So here's a terminal side, there's a terminal side, this is a terminal side, and this is a terminal side, okay? Now, given each terminal side, or if you're given a certain terminal side, then that's going to dictate where your reference angle is going to go. So let's read the definition again on what a reference angle is. It's the smallest angle that the terminal side of a given angle makes with the x-axis. So, right, if this was the terminal side, right, you guys, and you were to locate the x-axis, notice that you would be talking about this reference angle, right? If you're given this terminal side, and it's the angle made by the x-axis, notice that the angle would be this one now, right? So depending on the terminal side will dictate which reference angle you are talking about. Because the x-axis always stays, right? If you're talking about this terminal side, you guys, and there's the x-axis, what angle is formed, and it is that one, right? So that is what a reference angle is. And I should have written in the notes, but reference angle is positive. Okay, it's a positive angle. Okay, so let's take a look. All right, now here's a sample. Okay, so let's say you guys were given that 135 degrees and you're given that terminal side, right? Well, the reference angle, it's the smallest angle that the terminal side of a given angle makes with the x-axis. So we have to figure out where is the reference angle. Well, there's the terminal side, right? And here's the x-axis. So that means the angle measurement would be right there. So here's the reference angle now, which is this scenario, right? Now we just have to find what that measurement is. Well, do you guys notice how that terminal side from the standard position is 135 degrees, right? Well, if that's 135, do you guys know how much a whole half circle is? It's 180, right? So if that amount is 135, then how much is that amount? And it's 45 degrees. So this reference angle, you guys, is 45 degrees. You could do 180 minus 135, and you would have gotten 45 degrees. So that is pretty much how you guys find your reference angles, okay? Just remember, reference angle is the terminal side and the angle it forms with the x-axis. If you could get that part down, then you guys should be able to find all your reference angles. Okay. So to find a reference angle, the theta should be how it is on the right. Yes. This covers all cases. All reference angles are in those locations, and it depends on the terminal side on which reference angle to use. Yes. All right, so look at example 3, you guys, and example 4. So use your guys' notes or the notes from above, and you guys, I will give you guys 2 minutes. So try this out. Try to find the reference angle for both example 3 and example 4. Remember, reference angles are positive, okay? They're positive angles. 2 minutes, find example 3 and example 4's reference angles. And if you want to ask questions during this time, you may do so as well. Got like 30 seconds left. You have like 30 seconds left. All right, so let's see how you guys did, okay? All right, so reference angle, let's look it over, right? It's the smallest angle that a terminal side makes with of a given angle with the x-axis. So here's a terminal side for this one, right? Here's the x-axis. So the angle measurement should be right there. So here's theta. Now we just have to calculate how much that is. Well, this 330 degrees, you guys, that is almost a whole circle, right? So if we think about it and we're like, okay, we know that amounts a whole circle, 360 degrees, and if that's 330, then that means this must be 30 more degrees. Because, right, 330 and 30 degrees adds up to a whole circle. And there's your reference angle. Okay, example 4. There's a terminal side. Here's the x-axis. This is the angle measurement we're trying to find. So here's theta. Now, how much is that reference angle? Well, do you guys know how much a half circle is? That's 180 degrees, right? So if that's 180, then how much is that? Well, if I did 225 minus 180, that would give me 45 degrees. So that theta, you guys, is 45 degrees. Now, since it says negative 225 degrees, some of you might have written negative 45 degrees, but remember, we want our reference angles to always be positive. So that is angle measurement 45 degrees. And that's how you guys find your reference angles. You just have to remember, reference angle is always the terminal side and what angles form from the terminal side and the x-axis. That is always going to be your reference angle. Because if you did 360, that's 360 degrees, right? So then you already know that this is 225. If you did 360 minus 225, then that would give you this amount, which would have been 135 degrees. So you want to find, so depending on where it is, you want to be able to use what information you do have in order to get what you need. Okay, so I'm going to end the recording. That's the end of that lecture.